to more OGT practice. Today we're going to be working with angles and more. So I have some notes prepared for you. Hopefully you know some of this information already, but we're going to look at acute angles, right angles, obtuse, and straight angles right away. The right angle is very common. Right angle where you have 90 degrees, and the corner of every piece of paper is a right angle. So pretty much, hopefully you can identify those when you see them. Acute angles are open less than right angles, smaller, so they're less than 90. But if you're opened more than 90, that's called obtuse. And if you happen to be actually open so much that it's a 180 or a straight angle. Sometimes knowing the difference between an acute and an obtuse can help you when it comes time to guessing on some of the test problems. We also have the word supplementary. That's two angles that add up to 180, and here's a picture here. This brown reminds us of a straight angle, and so I have the straight angle separated into two parts, one acute and one obtuse. But whatever they are, they together add up to 180. We can kind of do almost a similar thing with the right angle. If you have two angles in a right angle, they're called complementary angles. And so we have a right angle, and we have that separated. And so the two things, they don't have to be equal to each other, but together they would add up to 90. And then another important concept that's seen a lot on the testing is that two lines, when they intersect, you only get two sizes of angles formed. They're called the vertical angles, the ones opposite each other, and they're alike. So the Y and the Y, these are both obtuse, they would be the same. These are both acute, the X's, they would be the same as each other. If you take one of each, you get a 180 again. Because if you take just one of each, you get that straight angle pair by looking. So that can help you remember, hopefully. Then, when we have parallel lines crossing by a transversal, so these two lines are parallel, and we have a transversal crossing them. In other words, we have two lines crossing up here. So again, that's a 180 rule. One X and one Y would make 180. Same down here, one X and one Y would make 180. And you can go this way as well. And when you have parallel lines, whatever happens up here, like Vegas, happens down here. So everything is, you could just take a snapshot of that and move it straight down here. So these two angles are the same because they're both the obtuse angles. These are the same because they're both acute, and so on and so on. And again, one of each makes 180. So if I were to tell you one of these, you would be able to calculate all 8 of those angles. We also have circles every now and then. A circle contains 360 degrees all the way around. So if you divide a circle into n parts, or in this case 8 parts, 1, 2, 3, 4, 5, 6, 7, 8, then 360 divided by 8 tells me that each section has an angle here. The angle inside each section would be 45 degrees. So that's what you can do, but you've got to remember that a circle contains 360. Triangles, the sum of the angle measures in a triangle is 180 degrees. So if you know some of the angles, you can subtract from 180 to find out the missing angle. Sometimes two of them may be the same. Let's take a look at something like that. We do have different types of triangles. The scalene triangle has 3 different sides and also 3 different angle measures. Because sometimes they ask you to identify what type of triangle you have maybe in future like coordinate geometry sections. The isosceles triangles have 2 equal sides, also 2 equal angles. And then there's the equilateral triangle that's 3 equal sides and 3 equal angles, so each angle must be 60. Because 180 for a triangle divided into 3 equal parts is 60, 60, 60. And triangles are also classified by their angles. This one here is called a right triangle because it contains 1 right angle. This is an obtuse triangle because it contains 1 obtuse triangle, or angle, excuse me. And this is an acute triangle because all the angles are open less than 90. Moving on to the quadrilaterals. Remember, triangles have 180 degrees, all quads. Anything that's 4-sided will have 360 degrees. But you have special quads with certain special angle patterns. Rectangles and squares, we know, have 4 90-degree angles. And notice, of course, 4 times 90 is 360. Many times I've seen the isosceles trapezoid on the testing. In the isosceles trapezoid, these two sides are the same and only one pair of sides is parallel. But also, these two angles, the upper base angles, are equal to each other, and the lower base angles. If you take one of each, again, one obtuse, that's obtuse up there because it's open more than 90, then the other one has to be acute. And again, if you take one of each, you will get 180. We see the 180 rule over and over again when we're working with our angles. Notice the parallelogram and the rhombus. The squished over rectangle is the parallelogram and the squished over square is the rhombus. So by squishing them over, the sides still remain in the same ratio, but now the angles are different. Once again, once you squished them over, now you have two obtuses and two acutes in both shapes. And again, if you take one acute and one obtuse, they will combine to make 180. So again, if we give you one angle, you should be able to find the rest. Then every now and then they go above four sides. If you want more than a four-sided figure, just add 180 for each additional side. So if you take 360 for a four-sided and add 180 to 360, you get 540 for the pentagon, which is 5 sides. Add another 180, that'll be 720, that'll be your hexagon of 6 sides. The heptagon is not usually used too often, almost 7 sides. So if we want to go to 8 sides, we're at 6, we have to add 180 twice. 180 plus 720 is 900, plus another 180 is 1080 for the octagon. And if you wanted to go to the decagon of 10 sides, it would be 180 plus another 180 more than the 1080 for the octagon. So that takes a little bit of work, but it's worth it in order to pass this test. So let's take a look at then some of the problems that I found on the OGT throughout the years dealing with angles. So here's one. It says when a marble hits a wall, it bounces off the wall at the same angle it hits. So it's coming into the wall, it hits at a 22, comes out at a 22. Okay, so this is related to what we've been talking about. If I put this, this is dark brown, if you can tell, this dark brown angle is a straight angle. So all of this adds up to 180. We've got 22 there, oops, and 22 there. So we would just take 180. You could subtract 22 and then subtract 22 again, or you could add up the 22s first and take 180 minus 44. Whichever method you choose, you will get 136 degrees. And again, looking at that picture, they don't try to fool you on purpose, unless it's part of the problem that you can tell. That is definitely an obtuse angle. So if I had no idea what I was doing, I would hope that I would eliminate A and B because those are angles that are smaller than 90. So it would have to be one of these obtuses, and by doing the math, we find out that it is the 136. Notice you can get the 158 if you subtract 22 from 180 only one time. So be careful. They figured out all the ways you might want to do it wrong. In this one, we want to know in which figure is the measure of angle 1 not equal to 60 degrees. Diagram A reminds me of what we've just done. We've taken a 180, a straight angle, and now we've got it into 3 parts. But 2 of the parts are 50 and 60. So if we take 180 and subtract 50 and then subtract 60, we will find out that we get 70 degrees for angle 1. That is not equal to 60. So I believe that A is the correct answer. However, since this test is fairly important, I want to go ahead and double check. In part C, I'm going across, I guess, to C, we have an example of 2 lines crossing. When 2 lines cross, once again, the angles opposite would be the same. This would be 120. This is 120, but that's not labeled as angle 1. Remember, those 2 together make a 180, a linear pair or a straight angle. So I would take 180, subtract 120, and I do get 60. That's why it's not C. In B, that's a right angle that's separated. So if you recognize it's a right angle, that's the little clue for right angle. If I take 90, subtract off 30, So angle 1 is 60. So it's not B because we're looking for not equal to 60. And once again in D, these are our parallel lines. And remember, whatever happens up here happens down here. So if angle 1 is there, it's the same as having angle 1 right here. So the angle 1 and the 120 are again two angles that add up to 180. Because I could make that, there's a 180 degree there. And you can see that the 120 is obtuse, and the number 1 on the other side is an acute angle. And again, we've already done it actually. We've done 180 minus 120 to be 60. So we found for sure that C, D, and B are all 60, but A was not. So A is our correct answer. When framing a wall, carpenters make sure that all vertical studs are perpendicular to the floor and ceiling. They sometimes add a diagonal brace for added support during construction. Otherwise, things can flop over. You've seen what can happen if you're not careful. Like if you have a square, if you don't support it, even though you think you have your nails in tight, if you have a square and don't support it, it can flop and turn into a rhombus. So that's why they sometimes use that brace. Now I'm hoping that you can look at those angles and identify them right away as either acute or obtuse. If you can do that, then you'll be able to answer the question, because this is nothing more than a bunch of parallel lines cut by a transversal. But there's more than two parallel lines. But that doesn't matter. Some people prefer to look at them this way. Whatever happens here, and here. So, according to what's happening in Vegas, staying in Vegas, 1 is acute, so is 5 acute, and so is 9 acute. Then if you look on the other side of them, 3 is acute, and 7 is acute. That leaves us with 4 being obtuse, 8 being obtuse, across from 8 is 10 being obtuse, 6 is obtuse, and 2 is obtuse. So our job is to identify which pair of angles will always be congruent if the vertical studs are actually perpendicular. That would make those lines parallel. So if you look, like color-coded, or we're looking for 2 acutes or 2 obtuses. 1 and 2, that's an obtuse with an acute. Nope. 3 and 6, nope, that's another acute with an obtuse. 5 and 7, 5 and 7 are both acute, so they should always remain the same. Double checking, 6 and 9, even though they're far apart, 6 is obtuse, 9 is acute. So this is our correct answer. So it's helpful, I mean, if you can identify it looking at angles, that's obtuse, and looking at that's acute. Because in this kind of situation, all the obtuses are congruent, and all the acutes are congruent to one another. Here's another one similar to the first one we did. They want to know in which figure is the angle equal to 45. So this is a review of what we've already done. This is a straight angle. All of this must make 180. So we can take 180, subtract off 45, and subtract off 45 again. That gives us 90. So that's 90 degrees, which is not 45. In B, we have parallel lines, again, cut by the transversal. And remember, whatever happens up here happens down here. So angle 1 is in this position here. It's not the same as the 145. It's the other angle. So we take 180 and subtract 145. That gives us 35. So angle 1 is equal to 35, not 45. Then C, although the picture's a little different, it's still the 180 rule. You've got a straight angle here with 2 angles adding up to 180. So 180 minus 145 is 35. So that's not it. So D must be correct. I see that this outside angle is 90. That's the marking. One of the angles is 45. Subtract, and you do get 45. So in part D, angle 1 does equal 45 degrees. Here's another one of those parallel lines. We have many parallel lines, and the question is, which of these angles will be congruent to angle 1 if all the side stripes are parallel. So this is a worker painting stripes for spaces in a parking lot. So that's kind of an application of parallel lines. So remember, whatever happens up here happens down here. So angle 1 is on the right side of that transversal line, and it's above the parallel line. That's where angle 3 is. So angle 3 and angle 1 would always be the same, but that's not a choice. Well, angle 3 is part of the choice. We have 3 here and 3 here. Now, what's the same as angle 3? Not the ones next to it. They make 180. The one across from it with 2 lines crossing would be the same. So 3 and 5 are the same, and since 3 is the same as 1, that makes 5 the same as 1. So it's answer C, with angle 3 and angle 5, angles across from each other. And again, you can always refer to your notes if that helps you. The notes are included in your packet if you've downloaded it. As we see here, this was angle 1, here's angle 3 and angle 5 across from each other. And then the same position on the different parallel lines. Okay, we've got a circle. This is referring to the flag created in 1776 by Betsy Ross. 13 stars arranged in a circle. And they have connected these two. So we could keep connecting and making that, dividing up that circle. So first of all, some people get a little confused on how many angles does that make. So let's draw them real quick. There's 13 stars. Does it make 13 angles or 12 or 14? Double check. So I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That does create 13 angles, having those 13 points on the circle. So we said if a circle has 360 degrees, notice you have to know that. It's 360 is not mentioned anywhere in the problem. But it's divided into 13 equal parts. And when you divide 360 by 13, we come up to about 27.7. And it does say approximate, so this has been rounded slightly because 13 does not fit evenly into 360. Now this reminds me of the notes we took on the different types of triangles. So this whole circle, the whole large circle, represents all the triangles in the world. These are the obtuse types. That's an angle greater than 90. These are the isosceles that have to have 2 angles the same or 2 sides the same. And then the equilateral triangles. We're supposed to be finding a triangle in the shaded region. So the shaded region means it includes obtuse and isosceles. So an obtuse has to have an angle greater than 90, and isosceles has to have 2 the same. So it can't be A. If you recall, A is the equilateral triangle, where all the sides are the same, and notice that is not touching the shaded region. So it's not A. I'm looking at B. I see an angle of 100, which is greater than 90, and I see 2 other angles that are the same. I believe it's answer B. Let's double check. C has 2 angles the same, but it has no obtuse angles at all. Nothing greater than 90, so it's not C. D has an obtuse angle, but the 2 other angles are the same, are not the same. So it can't be those. So I am convinced angle B is our picture. And again, you may have to refer back to your notes if you've forgotten what those are. But notice those are expected for you to have memorized in order to do well on this test. This one's a little tricky. Which one of these is not a parallelogram? And they're dealing with more than just angles. B has all sides equal to 4, so that makes it at least a rhombus. And a rhombus is one of the types of parallelograms. So it's not B. B is a parallelogram, so B is not the answer. D has opposite sides congruent. That's the conditions for a parallelogram, so this is also a parallelogram. Now we look at A and C. C has more information. Remember in the parallelogram, opposite angles had to be the same. But if you take one large angle, which is 93, a little above 90, and one smaller angle or acute angle, the one less than 90, they should add up to 180. Let's check for that. If we add 87 and 93, Carrie, that does make 180. So, and then a 360 rule would ensure that this angle is also 87. So these are all parallelograms. So this must not be a parallelogram. And it's pretty easy to tell, actually. I mean, like I said, you can't tell by looking with your naked eye between a 90-degree angle and an 89-degree angle, but they've marked these as 90s. And so if it's a parallelogram, across from each other should be the same. It's not. This is 90 and that's 89. So this is slightly off. If you were to do the math with your 360 rule, you would find that this one is 91. So in a parallelogram, opposite angles have to be the same. So those are a little off. This is actually some sort of trapezoid, but we haven't really talked about those in this type of a situation. Okay, now we're on to a shape that has more than 3 or 4 sides. So if you got to count your sides carefully, first of all. So the bunk beds aren't so important. It's the polygon that they've highlighted in dark here. So we've got 1, 2, 3, 4. We've got 5 sides. If you recall, triangles have 180 degrees. Quadrilaterals have 360 degrees. Then if you want to go to 5 sides, we have to add 180 onto 360. So this one has to have 540 degrees. So I can take my 540 and start subtracting off what they gave me. Hey, they gave me 90 once, twice, 3. I could either do 3 times 90 and subtract, or on my calculator I could just keep subtracting 90, making sure I subtract it 3 times. Then the other angle they gave me was 120. So I'm subtracting 4 angles, so the one that's left has to be what I get. Notice again though, this angle is an obtuse angle. Obtuse angles are more than 90, but of course it's not 180 or more than 180. This would not be the measure of an angle. These could be maybe the measures of a shape. So we're down to either 150 or 120. And if we do the math correctly, I believe we come up with 150 degrees. If you take 540 and subtract all that information, you do get 150. I'm not sure you can tell, maybe you can, I'm not sure your naked eye can tell that that's a 120 and this one is actually opened more than that 120. That's a little bit harder to tell. But I guess if you got a very good eye, you can tell that this angle is opened more. And as I said, they don't really try to trick you. So more than 120, the only possible answer would have been the 150. And our last one, of course, our hardest one for last. It says, Miss Chen drew a diagram for a new patio in her backyard. So notice her diagram is a quadrilateral, 1, 2, 3, 4 sides. So we know we're talking 360 degrees. But the information here, there's 2 angles missing, and you can tell by looking, the 2 angles look entirely different. This one looks acute and this one looks obtuse. Ooh, speaking of that, they want the measure of angle 2, so I'm just going to get rid of C and D. Those are definitely obtuse angles. 2 is got to be an acute angle. And that mentions, though, that angle 1 is 3 times as large as the measure of angle 2. I think maybe what we could do to make this a little easier is to take our 360 and subtract off the 290s so that we can, and you can either add them up and subtract or just keep subtracting them. That turns out to be 180. So angle 1 plus angle 2 has to make 180. But also, angle 1 has to equal 3 times the size of angle 2. So why don't we just take a guess? It's a multiple choice. Let's try 45 degrees. If angle 2 is 45, then angle 1 has to be 3 times 45. 3 times 45 is, of course, you can follow along with your own calculator or whatever, but that's 135 degrees. Does 135 plus 45 make 180? It does. So this must be the answer. I just want to double check though. I'm going to double check and show why it can't be 67.5. If angle 2 is 67.5 and I multiply that by 3, let's see, that's 15, carry 1, 2, carry 2, 18. That turns out to be 202.5 degrees. Notice that's already bigger than 180. But even if you tried to add 202.5 plus 67.5, again, that would be much larger than 180. So our answer again is A. So this finishes our discussion of the math problems dealing with angles on the OGT. Come back next time for learning about mean, median, and mode problems. Good luck.